Okay, so we are in an era of IT/OT convergence, and this is where enterprise digitalization comes in. So, what does Symmera do? Digital trust is the big story nowadays, right? So, what are the objectives of digital trust? What you need is verifiable and trusted machine identities, which is one of the important pillars of digital trust. You need to ensure scalability and availability with whether using certificates or keys. You need to also secure how content is distributed, not just with code signing, which gives you supply chain provenance, but also with proof of trustworthiness. And the reason for what's the difference between this is if you're familiar with what happened with CrowdStrike or SolarWinds, these are good actors, and yet code signing caused problems, right? So there's that one step of trust but verify. And last but not the least, you need trusted devices and trusted data because we live in the era of data. It's data-driven analytics. If you take out data, everything else is meaningless, right? So these are the four objectives that we address at Symmera. And why? What is driving this industry? Obviously, it's regulations and standards. There are several regulations. We heard about CRA this morning, and that's really at the top of the list. In industrial automation, IEC 62443, critical infrastructure is CIP, and there's a bunch of other ones, but last but not the least is the European Union's Artificial Intelligence Act, because where's data going? It's going to AI, like it or not. And what are the standards? And I think this morning you heard about this, is there's no standards. Well, there are standards, and there are various organizations when it comes to devices, like the Margo Alliance and Ethernet APL, FCG, so on, working on device standards. And then obviously you need protocols because protocol is an important element of security. And again, there are various protocols, standardized protocols based on RFC. And why that's important is interoperability. And then you have the industrial protocols, which is another cousin of the popular protocols setting out in the industry that people have never heard of. But millions and billions of devices are using these 20, 30-year-old protocols, and they're not going anywhere. They're going to stay. But all these protocols have upped their security to use TLS. So all of them have a cousin of theirs, which is the secure component, right? And then there's NIST with specifications all the way from the cybersecurity framework, 853 and so on, and then the quantum safe. So these are all the regulations and standards driving what we do. So I don't know what happened here. This is not showing as it should, but let me just continue. So what are the challenges ahead? The current technologies today were really designed for data centers, but the challenges are out in the field with devices that are not so modern and the new devices. So that's where the challenges start. The challenges are all the way from the application developers, right? The developers have technical complexity to deal with on devices. They have to deal with lifecycle management of not just their applications, but artifacts unrelated to what they do. And then you have in-field updates, and then they have to worry about, am I writing code that's going to work 20 years from now when this says RSA is gone or EC is gone? So these are long-lived devices, so the application developers have to think 20, 30 years down the road. And then there is the device manufacturers who have to deal with re-engineering of so many device families. It's a major cost for them to rewrite things. And they deal with multiple platforms, operating systems, processors, chipsets. So it's not an easy task for OEMs to say, I'm going to change my hardware or change something in the field. And then for the end users, the IT/OT convergence is on the top of the agenda for the CISO, saying if I have 10,000 devices today and you're bringing in 20,000 devices, it becomes my problem. Anything that has an IP address is my problem. And so that brings in a lack of automation, impact on devices. How do you observe these devices that belong to OEMs? And how do you manage remotely? COVID proved to people that they could not really service devices by sending technicians to the field. And then the scalability and availability is important. So that's basically the challenges. So what's the solution? So from Symmera's point of view, we offer a SaaS platform that is what does all the heavy lifting. So you take all the difficult tasks from the devices and make it something you put on the cloud or on-prem. So what we do is we harden devices so that you can meet your cyber resilience and regulatory compliance. And we automate operations all the way from factory to field, because the device's life cycle starts at the factory. There's a lot of pre-provisioning or late provisioning that happens in the factory. It goes in a box, goes on site, you power it on, you onboard, and then you have to manage the whole life cycle and updates, and you collect data. So all of this operation can be automated, and we'll show you how. And why are we doing this? Because all the data that's coming from the devices are going to edge gateways, they're going to cloud, and these are the MES and SIMSAM SCADA systems where they get processed. And so this is a complete journey of digital trust, from factory to the device, to how you digitally onboard something you trust, and then you send data, and then you process the data. So how do we simplify this? There are many ways of doing this, right? There are enough solutions out there, but the simplicity is really what's going to matter for Convergence. What we provide is zero coding utilities. You don't have to write a single line of code in order to do all of this, and we'll show you how. And then there's the other option, which is API based, which is very low coding, 2-week stops. And we'll show you with just 23 APIs, you can do everything. You don't need more than 23 APIs in any programming language. You can use your own SSL stack, your own crypto, we don't interfere with that. And then we have a concept of two-factor authentication for devices. Now this is not like user MFA. How do you two-factor authenticate a device before you give it its first certificate? Right, because that's where the trust starts. Zero trust, right? You can't trust a device, how will you give it a certificate? And we'll show you how. Now if you do that, what are the benefits? From the end OEM's point of view, what the OEMs are looking for is, give me something that's open standards based. Give me something that can have secure field communications for me in the field. I can interoperate with my competitors and partners, because it's always going to be a multi-vendor ecosystem. And most importantly, as an OEM, what they're looking for, acronym for that would be SASE: security, availability, scalability, and interoperability. And if it meets those check marks, then the next thing they say is, can you operate in an open environment, device to cloud? Can you operate in a highly controlled environment? Can you operate in an air-gapped environment? And so basically this is what the advantages are. And then if you're an end user, you're looking for operational efficiency. You're looking for zero touch. I want to discover my devices. I want gated workflows, so human errors do not cause disruption or any kind of impact to production. And that's really what the end user's goal is: enterprise digitalization and convergence. So the journey starts off at the factory, but ends with the end user and how they're able to digitalize. So what does it mean? So digital trust for IoT devices, from our point of view, is that if you look at the left side, which is your device, nobody is going to change anything from the processor, the operating system, the network stack, security stack. Don't touch it. You have what you have: OpenSSL, embed TLS, Wolf SSL, Boring SSL, you name it. Anybody's crypto library, post-quantum, classic, whatever. We put a layer as APIs for applications that can use our APIs and talk to our SaaS platform. If you don't want to write code, you can use our zero coding utilities, and we also are introducing an agent, installable agent. So what it means is, you can take a Windows or Linux platform today, install our utilities or agent, and without writing any code, you can get a lot of these benefits. Because what we have done is taken the intelligence out of the application and put it into the SaaS platform. Now through the APIs, our API layer on the device communicates with our services, and that's where you can write your security policies. That's why you manage lifecycle of keys, certificates, the metadata from devices, and you can also do updates to devices. You can collect any kind of information from devices and then forward it to the upstream without having to write code on your device to do a syslock connector or to do EST protocols. All these protocols are very intense for application developers on devices. So that's how we achieve this concept of scalability, security, availability, and interoperability, and allow trusted data from the device to flow through our SaaS platform, from where you can broker it by policy. You can take metrics and send it to a SIMSAM. You can take images and send it to OpenAI. You can take audio and send it to Azure AI, whatever is your favorite AI. And so what it means now is, from an architecture point of view, we don't see this as an OSI stack. That's legacy. What you're looking at is your connectivity plane. How do you want to connect with identity and authentication? Maybe you have a solution. In that case, you can look at the management plane. How can we help you there with lifecycle management and interoperability? Then there's the data plane, where you're harvesting data and attesting to the validity of the data, because if that data is not valid, you're not going to process it in your AI or process it elsewhere. And last but not the least is the analytics plane, where you want to take classified labeled data, which is really the big thing in AI. If your data is not labeled, it's going to be very difficult to really make that AI model work. Right? So that's where we come in with the multi-plane architecture with APIs. And so now when you look at what is this concept we call as the DIN, which is Distributed Intelligent Platform, you talk about smart devices and we talk about expert systems, what's in between? It's not just a plumbing, right? So that's why we look at the various verticals, energy, transportation, retail. All of them are looking for digital transformation with IT/OT convergence. And what are the four main things they're looking for? Device onboarding, trusted field communications, content distribution, and data to service. These are the four things they're trying to achieve. And with our SaaS platform and with zero to low coding, we can manage the complete life cycle of these gears all the way from onboarding to updating to sending data and lifecycle management. So that's basically how we bring those use cases in the various cross-vertical markets into this model. Now, when you look at how we work with Keyfactor, so obviously there are various flavors in which different industries choose to implement their solution. And we support all of that. So if you are a typical trusted public PKI interested party, then you can work with us through our platform. We backend to EJBCA. If you're looking for code signing, we backend to Sign Server. If you're looking for on-prem, you can do EJBCA on-prem. If you're looking for a very lightweight PKI in air-gapped environments, where you cannot take PKI to the device, you take certificate to the device. So you can put your millions of certificates on a USB stick, go into the past the electric fence and plug it in. So that's what we call as a sticker net, which is a reality in air-gapped environments. And we also have something called offline PKI. You may lose connectivity to the CA in certain environments. It happens in the Navy and so on. And then the trusted content distribution for supply chain, where this morning we heard about code signing. We have introduced another concept in addition to code signing called signature manifests. And that is basically what you can do to append proof of testing as an integral artifact that you deliver with your software to the device. The device checks signatures to make sure that there are people who have validated the testing, and then it checks the code signing and then it applies it. So imagine what would have happened with the CrowdStrike issue. Somebody, at least one person of the millions who were impacted, would have tested it and said the driver has a problem. Right? It's code signed, but it has a problem. So that did not happen. So that was a process failure. So we make sure that human errors do not cause mass disruption, especially in PKI. So where does it fit into the current ecosystem? Because no matter which ecosystem you go into, A, IT is not going to change the wiring closet for you. B, they're not going to change their processes for you. They won't even pinhole a firewall for you if they don't feel it's right. So where we come in a very controlled environment, which is, if you're familiar with the Purdue model, is where devices don't see the light of day. They are sitting in layers 0, 1, 2, and most of the nuclear plants and the critical infrastructure, they're not going to connect those devices that are insecure with an IP address to the internet. So they go through a maze of firewalls. So in this architecture, we don't change anything. We don't change your network management, application management, or device management. But what we bring in is an element that goes on the device with utilities or APIs. And then up in the cloud, we have the SaaS platform, which can be installed on-prem, or you can install it in a public-private cloud. And from there, we become the broker to the high-end analytics engines, AI, ML. So if you are a traditional device, a historic device, most of these devices in industrial automation don't write logs. And they don't have MQTT stacks. They have nothing. They may have TCP stacks. And now they are trying to migrate to TLS. So it's a very long journey for them. You think that it's difficult to use post-quantum with existing TLS. Imagine going from TCP to this, right? It's a longer journey. So what we do with our zero coding utilities is that we give command line utilities we can use on Windows and Linux, where if you want to register the device, you can use the DINREG utility, which is one API in C, C#, Java, Go, Rust, whatever language, one API. We authenticate the device, we get all its attributes, and we register the device. If you want to get a license to the device, OEMs are interested in making sure that they can issue a license to the device, one command, one API. If you want certificates, 3 APIs at tops. And the application developer does not have to understand protocols. This is who I am, give me my certificate. Oops, my certificate is expired, give me the renewed certificate, that's it. Right? So applications should never go down, high availability. For whatever reason, if your certificate could not be renewed before it expired, and the application realized that the server just bounced back saying expired, make an API call to us, get your new certificate, continue. You should never go down. But if you use the utilities, obviously you will update that before it expires. If you want updates, 3 APIs. Query for my update, get my update, apply my update, tell the SaaS platform I'm up to date, I'm in sync. Right? And same thing with signing and verifying. Just we have one API to sign, one to verify. So and metadata, you can send any kind of data from the device. Metrics, events, logs, images, audio, video with one API in any programming language. Right? So that's basically our utilities which use our APIs. But if you want to look at what does the API look like, there you go, that's the APIs. You simply open a connection which uses two-factor authentication, very secure. This concept of two-factor authentication leverages a root of trust in DNS, a root of trust in DHCP, and a device unique join key, which can be rotated at whatever speed you want. You can think of it as a passkey for devices, literally. So that's a secure connection from the device to our SaaS platform. We do not interfere with the data path. Your data path is your own. You're just doing a side channel to us. And here, depending on what you want to do, you just call those respective APIs. And most of the times, these are exclusive. In the sense, if you're using symmetric keys, you may not use certificates. If you're using certificates, you may do it local keygen or a server-side keygen. So you want to use all the APIs. So that's pretty much what it is. You want to do an update, you got 3 APIs for secure updates. You query for your update, you retrieve your update, apply it, just notify us what happened. So that's this is a cheat sheet for developers saying this is all I need to use. So we'll take questions at this point. We can flip back to any slide, and Shreya will can help you with your questions. So we have about 6 minutes left. So
anyone have a question?
We do have demos that you can schedule through our website, and we are here for the next day, today and tomorrow. If you want, we can do a quick demo for you here.
Yeah, just please grab us, and we're happy to talk to you, understand your use cases, give you a demo, show you what the utilities and the APIs that we use live in action. And just to reiterate what Srinivas said, right? Managing certificates, for instance, with EJPCI, everybody knows how to do that with enterprise systems and for users, right? But when it comes to millions of devices, that's where the problem is. How do you manage the life cycle of certificates on these devices, right? How do you issue them? How do you renew, rekey, revoke them? And now these application developers, they are focused on their business applications, right? They're not security experts. That's where we come in. We make it very easy for them. And I'll give you a customer use case. So, for example, there's a retailer who's getting devices from hundreds of different vendors. And each vendor's device is completely different. Some of them are Linux, some of them are Windows, some of them are real-time operating systems with very little, few resource capabilities. So how will these devices manage the certificates on them, right? So that's where we take the complexity out of the devices and we manage the complexity on the SaaS platform. The device will just say, give me my certificate, give me my key. Do I have any updates? I don't know anything else. Just use our few 23 APIs. If I want the certificates, I have 5 APIs to use. Just give me my certificate. We'll take care of everything. We'll take care of identifying, authenticating, onboarding the device, issuing the right certificate to it, managing the life cycle of it. SBOM is very important, making sure that the updates that are sent to the device are validated. Every person in that approval chain has actually approved it, digitally signed it. We take care of all that. And we provide a very seamless integration with EJPCA. We're happy to do a live demo for you. Yeah. So please feel free to hit us up.
So we are also working on the content distribution side where, like Shreya just mentioned, when somebody gives you a zip file saying, here's an update for your transformer. Well, it may have come from the vendor, but you want to first check, show me your release notes, show me your SBOM. I want to check if in your SBOM you fixed 6 CVEs and you introduced 4. Now I need to check. You fixed 6, but you hit me with 4 new ones that came out. Should I send this update? Should I reject it? Right, so there's the transparency of the SBOM, the release notes. There's another concept called artifact dependency graph that CISA is working on, which actually can trace back to how you compiled your code, what was baked in. And that will also point to the Kiv database, the VEX database. So we look at the Kiv database, VEX database, we parse the NIST CVs, and we tell you, if you apply this content, these are the CVs that are fixed, these are the risks that are introduced because of these threats. Do you want to continue with the update? Right, so that's basically a transparency. And this is even before you look at code signing. So we're going to the next level of content distribution because in the devices world, the device update goes to 1 million devices. So they're going to say, should I push the button? Because there's no recall here. It's a factory recall of the device, not a recall of the update if I send a wrong update to the device.
Wonderful. All right, well, if there's no more questions, thank you very much. Appreciate it.
Thank you, everyone.